Okay, so my name is Wajahat Chima, and I will be doing homework number 3, question number 2. So for question number 2, x is a random variable with the PDF f of x to x equals e to the negative x plus 1 with the unit step function shifted to the left by 1, which is just x plus 1. And y equals g of x, where g of x equals the absolute value of x between this interval -1 is less than x, which is less than 1, and 0 otherwise. So that we can graph g of x. It's a pretty simple graph. It's the absolute value, it's 0 otherwise, so this will be g of x right here, and we should keep this graph in mind to further continue the problem. So for part 1, we have to find and we have to draw small f of y. So you can do that using the fundamental theorem, which is f of x of small f of x over g of x. But as you can see from the graph, we have it's not continuous. We have a positive side and a negative side, so we can split that up as such right here, and then we can start replacing this with the positive x, this with negative x. So if you replace with positive x, small f of y equals e to the negative x plus 1. Replace x with negative x plus e to the negative x plus 1. And as you can see, this is f of y. You have to write it in terms of y. So that will be small f of y equals e to the negative y minus 1 plus e to the y minus 1. And you gotta make sure you see how there's a 0, so this is 1, so y is only going from 0 to 1, so that will be the interval right here. And you have to make sure keep this intervals in mind for y. So for y equals 0, to find the value for when y equals 0, we can use a limit from 1 to infinity. That's when y equals 0, from 1 to infinity. So that will be the limits. We can use e right here. We can just solve this quickly, and it gives us negative e to the negative x plus 1 equals e to the negative 2. So small f of y equals e to the negative y minus 1 plus e to the y minus 1 from 0 to y to 1 equals 0 when y is greater than 1, equals 0 when y is less than 0, right here, greater than 1 right there. And then when y equals 0, it's e to the negative 2 with the impulse function. So graphing that will be pretty simple. This will be the graph for it. Right here, you see a little increase over there, starting at e to the negative 2. And this will be f of y. Alright, so part 2 is asking us to draw big f of y. So to get big f of y, we have to integrate small f of y. So make sure you guys integrate that properly from 0 to y, e to the negative y minus 1 plus e to the y minus 1 dy plus e to the negative 2 dy. So simple integration gives us this from 0 to y plus e to the negative 2. And if you keep continuing calculating, negative e minus y minus 1 plus e y minus 1 plus e to the negative 1 plus e to the negative 1 plus e to the negative 2. And then this will be your final answer for the integration, negative e to the negative y minus 1 plus e to the y minus 1 plus e to the negative 2. And to get f of y, when from 0 to 1, this will be the answer. The integration will be the answer. When y is less than 0, you can see right here, when y is less than 0, it's just going to be 0. When y is greater than 1, it's just going to be 1. And when y equals 0, you can see that it's going to be e to the negative 2, because plugging it in, e to the negative 0 minus 1, this would just give us negative e to the negative 1. This would give us positive e to the negative 1, so they cancel out. So when y equals 0, it's e to the negative 2. See a little exponential increase to 1, and then you see it becoming constant. And this will be the graph for big f of y and y. And that would conclude question number 2. Thank you for watching.